Now let us understand a very important concept, that is inverse of a function. Suppose consider that f is a function from set a to b, and it is 1 onto function defined as y equal to f of x. Then there exists a unique function, say g, from set b to a. That means now we are interchanging the two sets, that is from b to a, such that g of y is equal to x. And this function g is called as the inverse of the function f and is denoted as f inverse. So this is the symbol for inverse function. Let us understand this definition with the help of one example. All right. Let us consider a set A which has, say, 3 elements in it, that is 1, 2 and 3. Alright, and let's consider another set B which also has 3 elements, say 2, 4 and 6, and the function f is defined by connecting the elements as shown here. So 1 is connected with 2, 2 is connected with 4 and 3 is connected with 6. So it's not difficult to observe that the function basically doubles the input, and that is why 1 gives us 2, 2 gives us 4 and 3 gives us 6. Now if you observe, this particular function is 1 type because we have 1-to-1 relationship, as well as it is onto because all the elements in second set have the pre-image in set A. Right now this function f satisfies the condition which is mentioned in the definition of the inverse. So if f is 1 onto defined as y equal to f of x, then there exists a unique function g from b to a. So that means now what we have to do is we have to now invert, or rather we have to switch the two sets. That is, now b becomes our first set, a becomes the second set. So here 2, 4 and 6 are the elements of first set and 1, 2, 3 are the elements of second set. Now g is a function such that g of y is equal to x. Alright. So what it means is, see, if we denote x as some element in the first function a with respect to function f, then it gets mapped to some element denoted by y, isn't it? Therefore we call y to be equal to f of x. Now if we interchange the sets, what happens is, now x which was 1, now it will go and sit in the second set which is a now, and hence y which was in the second set initially, now it will be the label for the element in the first set which is b now. So what does the inverse of the function does is, it maps this y back to x, and that is defined as the function g, which is called as the inverse of the original function. So that means, say for example, we start off with element 1. Alright. Now from 1, f is the function which takes us to 2, and g is the function which takes us back from 2 to 1. Alright. So therefore g is called as the inverse function. So this is what the inverse function does. But a very important condition for inverse to exist is that the function must be 1 and onto. Both of 1 and onto types are required for a function to have its inverse to exist. Right? Now let us understand why this condition. So let us see what happens if the function is not 1 onto. Right? So why the prerequisite of 1 onto for inverse to exist? So let's consider the other 3 types, that is 1 into, many 1 onto, or many 1 into. Alright. So let us consider a very simple example, that is set A, set B. Now this is 1 into function. That means let's consider this function. We observe that it is 1 1 because it's 1 to 1 relationship seen, and it is into because there is at least one element in the second set B which is not mapped with any element in first set. Now keeping the same arrows, if we flip the sets, because now we must have B as the first set and A as the second set, isn't it? So therefore now if we exchange the sets, here we observe that whatever is this relation shown in this particular figure, is this an inverse first of all, and is this a function? Now we observe that for the definition of the function, each element in the first set must be covered. But here we see that element 6 in the first set does not have any image in the second set A. So therefore this inverted relation is not a function at all. It is just a relation, but it is not a function. Alright. So therefore if the function is 1 1 into, then its inverse does not exist. Now let's consider the second case, that is what happens if we have many 1 onto function. So if we have say 1 2 3 and say something like AB, alright. Now here it is clearly many 1 because 2 and 3 map to the same element B, and it is onto because entire second set is covered. Alright. Now let us see what happens if we flip the sets. So here B becomes the first set which contains A and B, and A becomes the second set which has 1 2 3. A is linked with 1 and B is linked with 2 and 3. Now here no doubt all the elements of first set are having some images, but there is a problem with element B, because if you see B has 2 images 2 and 3 in the second set, and as per the definition of the function you cannot have multiple images for the same pre-image in the first set. So therefore this particular inverted relation is also not a function. And lastly let us consider the case of many 1 into. So here you have 1 2 3 and let's say here we have ABC. Here we see that it is many 1 because once again 2 and 3 map to B, and there is an element C which is unmapped in the second set. So this particular function is of the type many 1 into. Now what happens if we interchange the sets? So ABC is the first set and 1 2 3 is the second set. A is linked with 1 and B is linked with 2 and 3. Now here there is twofold problem, because first of all there is one element which is unmapped in the first set, so that itself makes it not a function, and additionally the element B has 2 images. So because of that also this particular relation is not a function. So therefore you see the importance of the condition of 1 1 onto for the inverse of a function to exist, right? And we know that 1 1 onto is also called as a bijective function. So we also remember that terminology also, that is for a function to have inverse, that function must be a bijective function, right? Now let's see a few important points. That is, note that f inverse of x does not mean 1 upon f of x, because we might be very much accustomed to the algebraic notation. That is, in algebra we know that say x raised to minus 1 means 1 upon x as per the notations or conventions related with negative indices. But here the minus 1 which is written as a superscript of f, right, that does not mean the reciprocal, it means the inverse of the function. Okay, so that is important point. And secondly, as we have seen, f of x is said to be invertible if f inverse exists. So the word invertible just means that the function can be inverted or its inverse exists, right? So now based on this we will see further properties and the procedure to find out the inverse of a function.